let's talk about last part of introduction. We have already studied what a damping torque is, okay, in part 3. Now we are going to study how to reduce damping. Here we have air friction, okay. In air friction method, what we do, the piston attached to the pointer is surrounded by an air chamber. Here air provides friction for this pointer oscillation, okay. This method is good where low magnetic field is there. Examples are moving iron and electrodynamometer type instruments. Then we have fluid friction damping. Here fluid has this piston submerged, okay. Now this fluid is providing some friction for the oscillation, okay. So this method is good for electrostatic instruments, okay. Then we have eddy current and electromagnetic damping. Here what we are going to do is the eddy current is stopping this pointer from oscillating, okay. Here you can see this particular diagram. The eddy current is flowing through this coils and the pointer is attached here. The oscillatory motion is opposed by this eddy current, okay. So this method is good for high magnetic fields. Examples are PMMC, okay. Then we have errors in meter. There are 3 types of errors: the frictional error, temperature error, and frequency error. When it comes to friction, what we do, we are using light-weighted pointers, that of aluminium, okay. We use stout suspension. These are your spring and this is your moving element, okay. This is used for reducing your frictional errors, okay. It is used in galvanometer class requiring low friction and high sensitivity, okay. Then we have temperature error. As you know, resistance is varying with temperature, okay. As temperature increases, the resistance also increases, which indeed varies the current through it, okay, which leads us to wrong reading. So what we do, we use shunt and swap resistance of low temperature coefficient to avoid this error, okay. Low temperature coefficient means if you increase the temperature too much, the value of resistance doesn't increase, okay. This is an expected condition when you have to reduce temperature error. Then we have frequency error, okay. The supply frequency may change, leading us to wrong value, and you know the number of losses also vary on frequency. This is causing more error. So what we do, we submerge this disc in a damping oil, okay. So what this does is, this is reducing the frequency error, okay. We are reducing the frequency. So this is all for introduction, and this entire sheet, this entire chapter 1 has been completed.